complete syllabus with best solutions.
आपको मिले
गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस।
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की, हो जाता यार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो ये बन गया।
इलेक्ट्रिक फील्ड का फंक्शन क्या होगा?
Then it will be off. गुड इवनिंग एवरीबॉडी, कैसे हो आप लोग? वेलकम टू द क्रैश कोर्स ऑन नेटवर्क एनालिसिस। वेरी गुड इवनिंग ऑल ऑफ यू। जस्ट अ मिनट। Yes. So welcome to the crash course. Today we are going to discuss Thevenin's theorem and also maximum power transfer theorem, that is in the network theorems concept. Tomorrow I will finish the network theorems. So this is about me. This is Bhima Shankar Mantina. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertised with the subjects of digital circuits, network analysis, microprocessors, almost in all corners of the country. In the last 10 years, I taught to several students like you. I am very happy to share my knowledge with all you guys. So this is my profile name in Unacademy. You can go through it. Just follow my profile. You can watch all the free classes of mine completely free for you. If it asks any code, you can use this code Shankar 10. Right? Next. If you want to take an Academy Plus subscription, why to take an Academy Plus subscription, sir? What are the advantages? If you download an Academy learning app, you will be finding how, you will be understanding how interactive is our learning app. So if you watch the classes in Unacademy, definitely you can feel the difference how interactive our classes are, and you will feel the difference definitely, though you will be having the feeling of one-to-one. So if you take an Academy Plus subscription, you have some extra multiple benefits. Let's see what are the benefits. You have the live classes morning and evening, and generally it will happen in between also, sometimes it is there. but you will not you will not have any restriction. You can watch the classes any number of times without any restrictions. Okay, and you will be having crash course, rank improvement. You will be having the classes in both the languages, English and Hindi, and you will be having the doubt solving sessions, weekly exams, monthly exams, unlimited test series. Everything is free. Once you join Unacademy, you will be having multiple batches with only one subscription. So whichever batch you like, you can attend. You can attend all the batches if you have the patience. So it is purely depends on your requirement. So you can watch it in live and recorded. This is available only with Unacademy. Unlimited number of times. Okay. So if you go for Iconic subscription, in Iconic, you have extra advantages like personalized digital coach will be assigned for you, who will guide you to reach your destination 38,500 and 44,000. But after discount, you will be getting it for this particular price. So if you are a 2022 aspirant, you can go for 18 months. 2023 aspirant, go for 2 years. Okay. So both the batches are started day before yesterday. That is, you have seen the video, I think. SN and M को खत्म किया, बहुत सारे प्रॉब्लम्स किया सुपर पोजिशन पे. इसके बाद थेवेनिन्स भी डिस्कस किया. थेवेनिन्स में भी 1-2 प्रॉब्लम्स किया. राइट. सो इस वाला क्वेश्चन को आंसर कर लो. So please answer this question, read the question and give your opinion. Whatever you feel, give your opinion. क्या हुआ, स्ट्रेंथ कम है? Okay. So the statement, please comment guys. 2 PM display क्यों रहा है? I don't know. Okay, anyway, answer the question. Answer the question guys. An ideal voltage source and current source are connected in parallel. मेरे पास एक ideal voltage source है और current source दोनों parallel में connect किया तो उस वाला नेटवर्क में क्या होता है सर? थेवेनिन्स नॉर्टन्स दोनों पॉसिबल, थेवेनिन्स पॉसिबल, नॉर्टन्स नॉट पॉसिबल, नॉर्टन्स पॉसिबल, थेवेनिन्स नॉट पॉसिबल, दोनों नॉट पॉसिबल. विच ऑफ द फॉलोइंग इज द राइट आंसर? ऑप्शन सी. महेश और गौरव क्या दिया? ऑप्शन सी. ऑप्शन सी क्या है सर? नॉर्टन्स बट नॉट थेवेनिन्स. रॉन्ग आंसर. ठीक है. सो व्हाट इज द राइट आंसर सर? किसी भी ने आंसर दिया क्या? एनीवन हैव गिवन द आंसर? ऑप्शन डी नाइदर नॉर. ऑप्शन ए. ये क्या है? ऑप्शन ए भी दिया, ऑप्शन डी भी दिया, बट ऑप्शन बी आपका आंसर. कोई भी ऑप्शन बी टाइप नहीं किया. सारे लोग ए डी सी पे चला. व्हाट इज द राइट आंसर? इज बी. लेट्स गो, लेट्स ट्राई इट. सो आपके पास एक आइडियल वोल्टेज सोर्स और एक आइडियल करंट सोर्स दोनों है. सो इसमें पहले थेवेनिन्स निकलेगा, इसके बाद आई विल ट्राई टू फाइंड द नॉर्टन्स आल्सो. लेट्स फाइंड थेवेनिन्स. फॉर फाइंडिंग थेवेनिन्स व्हाट टू डू? सिंपल ट्रिक. What is the Thevenin's voltage definition? It is the open circuit voltage measured across the terminals. If you make this current 0, what is the open circuit voltage measured across the terminals? V. Next, if you replace the voltage source with a short circuit and current source with a open circuit, for finding which resistance? Thevenin's resistance. What is your RTH? RTH will be equal to 0, because what is the definition of RTH? Is the resistance measured by making independent source equal to 0. So ये दोनों करने के बाद आपका Thevenin's equivalent of the network क्या होता है सर? It is a VTH series with RTH में V आएगा, RTH 0 होता है. ठीक है सर? This is the Thevenin's equivalent. Fine. Let's try to find Norton's equivalent for this question. इस वाला क्वेश्चन में Norton's equivalent निकलेगा सर. Norton's क्या होता है सर? this is V, this is I. Okay, so try to find Nortons. Nortons के लिए क्या करना सर? शॉर्ट सर्क्यूट करना. आप लोग शॉर्ट सर्क्यूट किया तो ISC निकलेगा. For finding ISC, if you replace this with a short circuit, this is what we call violation of KVL. Ideal voltage source का parallel में क्या हुआ सर? Short circuit. V parallel with short circuit. Okay, if you apply KVL, it will not be satisfied. This is violation of KVL. Or you can find this current I, but you cannot find this current. That is ISC can be I plus any value, because the current through the ideal source can be any value. इसका मतलब क्या सर? इसमें नॉर्टन्स पॉसिबिलिटी नहीं है, थेवेनिन्स तो पॉसिबल है. सो आंसर क्या होता है सर? थेवेनिन्स बट नॉट नॉर्टन्स. थेवेनिन्स बट नॉट नॉर्टन्स. एक और हिंट भी है, अगर आपके वोल्टेज सोर्स का पैरेलल में कुछ एलिमेंट है तो मैंने इक्विवेलेंट सर्क्यूट्स में बताया ना, यू कैन नेग्लेक्ट दिस. एनी एलिमेंट पैरेलल विद द वोल्टेज सोर्स कैन बी नेग्लेक्टेड इन द एनालिसिस. ये तो प्रूव भी किया यहीं पे. Any element parallel with the voltage source can be neglected in the analysis. In the equivalent, you can simply have V only. So what is the dual analysis for this? What is the dual analysis for this? Instead of voltage source and current source in parallel, suppose they are in series. Okay. If they are in series, then what is the answer? Nortons but not Thevenins. Okay, if they are in series, Nortons but not Thevenins. Let me take your doubts. Okay, it's not the same, Pushpendra. It depends. ये क्या होता है? It will be little different. ये तो क्रैश है ना, थोड़ा सा फास्ट चलेगा. Okay, Gaurav, Nortons means short circuit current is to be calculated. If you want to find the short circuit current, whenever it is short circuited, the current through this branch cannot be calculated, because voltage source short circuit हुआ तो it is called as violation of KVL. It is not a valid condition. So what is that? This circuit is not valid, or you cannot find ISC in this case. Okay, chalo, is it clear, Gaurav? Next question. This is an important question. I think somebody asked me in yesterday class also. Sir, bridge में unbalance हुआ तो what to do? How to find its response? This is an example. Okay, let's do it. Okay, so listen here. Listen please. Okay, just a minute. Pushpendra, if you want, attend every single class and then you decide. Don't come in between 1 or 2 classes and ask all these questions. Don't disturb the regular class. Okay? You attend 1, 2, 3 first classes, then you will understand what you will get in this course, what you will not get in this course. If you are regular, everything will be, you will be getting it. Okay? Come regularly, then you will understand. Please attend the first 2, 3 classes. You will get all your answers. Okay? Gaurav, what is that? सर नॉर्टन्स आइडियल वोल्टेज को एज यूजुअल रहेगा. नहीं, नॉर्टन्स तो पॉसिबिलिटी नहीं है इस पे. नॉर्टन्स का मतलब शॉर्ट सर्क्यूट करंट, ये तो हमको नहीं मिलेगा. इट इज इम्पॉसिबल टू कैलकुलेट ISC हियर, बिकॉज व्हेन यू शॉर्ट सर्क्यूट द वोल्टेज सोर्स, इट्स करंट विल बी V/0 इंफिनिटी. सिंपल सी बात है. और यू अप्लाई KVL इज नॉट satisfied here. So in this particular case, Nortons is impossible. Okay, so let's do it. Chalo, I am having a input resistor and 5 ohm resistor. You need to find the current I. Is it a balanced bridge or unbalanced bridge? आप लोग बताओ. 10/6 equal to 15/8. Bridge is not balanced. Then what to do, sir? Bridge balance हुआ तो you can neglect the shunt. If bridge is not balanced, you can if the bridge is balanced, you can neglect the shunt. Not balanced. What to do? You cannot apply delta star. Why, sir? If you apply delta star, what happens? This bottom part will be disturbed. So फिर क्या करना, sir? You can find the node analysis one method. Otherwise, you can go by Thevenin's. So remove this branch between A and B. Remove that branch between A and B. Find the Thevenin's equivalent of the network between AB. Okay. And now, what to do, sir? Now, connect the 5 ohm. What is the answer? VTH by RTH plus 5. हो गया सर. अभी क्या करना, आपका जॉब तो बहुत आसान है. VTH और RTH निकालना चाहिए. You need to find VTH and RTH. Let's do it. Okay, let's give a try. So now listen here. How to find VTH in this case? First I will explain in a conventional way. Then I will give you shortcut to remember this directly. This is 100. This is 10. And this is 6. This is 15. 8. If you remove this, you need to find the VTH. So if you take this voltage as VA and this voltage as VB, what is VTH? You tell me. KVL say VTH will be VA minus VB. VTH will be VA minus VB. What is VA, sir? What is VA? If you see these two resistors are in series across 100 volts, you can apply voltage division principle. आप voltage division principle apply किया तो 100 into आपका resistance 6 by पूरा resistance ले लो 10 plus 6 minus what is VB, sir? 100 into 8 by 8 plus 15. Okay, so now listen here. This will give you calculation part, you do it, you get 2.7. You will get the doubt, sir, why you took in the bottom only? Can you take it in the top part and find the VTH? Definitely you can do it. Let's do it. Let's do it. ये आपका VA dash, ये आपका VB dash. So see here. I'm sorry. If you apply KVL in the top loop, VA dash minus VB dash plus VTH equal to 0. आपका VTH क्या होता है सर? It is VB dash minus VA dash. What is VB dash, sir? This voltage, that is 100 into 15 by 10 plus 15 minus 100 into, sorry, 15 plus 8. 100 into 10 by 10 plus 6. You try by this method also, you will undoubtedly get the same answer. If you check it at home, you can find the VTH from the numerator part or denominator part, both will give you undoubtedly same answer. Now how to find RTH, sir? How to find RTH, sir? Let me do it. Let me do how to find RTH. So for finding RTH, what is the definition of RTH? It is the resistance measured when independent source is made equal to 0. Let me make the independent source in the network given by the examiner equal to 0. Then ओके, दिस इज द क्वेश्चन गिवन. 10, 6, 15, 8, 100 को रिप्लेस किया शॉर्ट सर्क्यूट से. ओके, नाउ you can see here ten, 6, 15, 8. Okay, then what is the RTH? 10 parallel with 6 plus 15 parallel with 8. It will give you 8.96 ohms. Okay, then what is the VTH? You got it. Is RTH? You got it. What is the current formula I have given? VTH by RTH plus 5. So 2.71. Calculation part you can do it and cross check at home. Okay, I am repeating. If you have a network like this, first if you want a response in a particular branch, remove that branch. Across the branch, find the Thevenins. इस ब्रांच पे रेस्पॉन्स चाहिए तो इस ब्रांच को रिमूव करो, इसका अक्रॉस पे Thevenins इक्विवेलेंट निकालो, ब्रांच को कनेक्ट करो, करंट इज इक्वल टू VTH by पूरा इम्पिडेंस. How to find VTH is go by this method. RTH is replace the voltage source by short circuit and find it. If it is current source, we replace with open circuit. चलो भाई. So now let me give you one generalized way to write the answer. आपको किसी भी क्वेश्चन पे ब्रिज आएंगे तो डायरेक्टली नेक्स्ट टाइम से डायरेक्ट फॉर्मूला ऐसा ले सकते हैं. This is your bridge. Okay, what is the Thevenin's equivalent between A and B? Is direct formula. VTH is equal to V into R2 by R1 plus R2 minus V into R4 by R3 plus R4. And also, what is your RTH, sir? If you replace the voltage source with short circuit, R1 parallel with R2 plus R3 parallel with R4. You can remember if you want. This is the simplest way to write the Thevenin's equivalent of the unbalanced or any bridge in fact. Okay. Any queries you can ask, else we will move. Okay. If who is that? Kumar. If polarity is reversed, you take minus. What is there in it? If polarity of the voltage source is reversed, in place of V, take minus V. That's all. Okay. Shall I move further? Okay, next question. So, you can try these questions as homework. Right, give a try to this question. Please try this question. आप लोग ट्राई करके आंसर बताओ. मैंने नोट्स अपलोड किया, कल क्लास तक पूरा नोट्स अपलोड किया. डेली एट नाइट आई विल सिट एंड आई विल अपलोड once in 1 day or 2 days. I will definitely upload the total notes. You need not worry to write the notes. I am what we call assuring you, definitely I will give you the notes, no doubt in it. You need not worry about notes at any point of time. Okay, okay, read the question, try it. Very good. Option A, D, 9 volts, none, different answers. Please listen here. ये तो 2 एम्पियर 5, इसमें भी 2 है, 2 2 कितना सर 4 होता है. So most of the people will say 4 plus 5 9. Wrong answer. You should consider the voltage across the current source. We have discussed this point already. What is the voltage across the current source? It can be any value. What is the voltage across the current source, sir? It can be any value. It depends on the remaining network of the remaining part of the network. Based on the remaining part, इसका value can be anything. इसका मतलब क्या होता है सर? What is the value of V? 4 plus 5, 9 plus any. V can be any value. It depends on the remaining part of the network. Is it clear? So because this voltage is to be considered, don't neglect. Voltage across the current source is also there. That you should know to find V. That is, you cannot find V from the given information. So take the option as none. Because the current source, ideal current source ka voltage can be any value. Very good. Next question. डिटरमाइन द इनपुट रेजिस्टेंस ऑफ द नेटवर्क. आप लोग ट्राई करके आंसर बताओ. Give your answer, guys. Zero. 2.5. Very good, very good. Most of you have given right answer. 2.5. See here, in parallel, voltage is same. So 10 by 10, 1 ampere. 10 by 5, 2 ampere. This is 1. 1 plus 2 plus 1. What is this? 4. So what is the input resistance here? Input voltage by input current 2.5. Don't try to find the what we call Thevenin's resistance. Thevenin's is a different concept. Thevenin's neglect the resistance offered by the independent sources. But if you want to find RTH, you should consider VTH. Then only RTH is valid. Okay, only input resistance is required. What is that? This voltage by current ratio. So you can see here, if you find RTH, you should replace this with open circuit 10 parallel with 5, 10 by 3. That is different. Input resistance is different. Okay, shall we move to the next? Right. So please listen here. The next model. Model 2, you will be having network with both independent and dependent sources. Okay, here RTH can be obtained by VTH by ISC or V by I ratio method, that is multimeter method. Please wait, I will explain. अभी तक हमने प्रॉब्लम्स डिस्कस किया ना, वो प्रॉब्लम्स में व्हाट वी डिस्कस इज ओनली नेटवर्क विथ इंडिपेंडेंट सोर्सेस. नाउ वी आर गोइंग टू डिस्कस द प्रॉब्लम्स वेयर यू विल बी हैविंग द नेटवर्क्स विथ बोथ इंडिपेंडेंट और डिपेंडेंट. अगर दोनों सोर्सेस आपके पास है तो if you have both independent and dependent sources with you, then what to do? If you have both independent and dependent sources are available with you, what to do? We need to find the VTH directly, ISC directly, but RTH cannot be find directly, because when you find RTH, we replace independent source with short circuit, but dependent source को as it is लगेगा. अगर dependent source को as it is लगेंगे तो क्या करेगा सर? You should find RTH equal to VTH by ISC. One method नहीं है तो apply multimeter method. Apply some voltage, assume current flowing voltage, current ratio will give you the resistance. Any method is okay. So let's find by any of our methods. So let's try the question. Determine the Thevenin's equivalent of this network. You can observe the difference now. This network contains both independent or dependent. Okay, let's do it. So here, this is I want to find its VTH. If you make this current equal to 0, इसका current 0 किया तो अगर this Vx equal to VTH, okay, then this Vx is equal to VTH, or this Vx by 4k can be written as VTH by 4k. ठीक है सर, समझ हो गया. अभी ये करंट 0 है तो ये वोल्टेज और ये वोल्टेज क्या होना चाहिए सर? सेम होना चाहिए. ठीक है सर, हो गया. इसके बाद क्या? अप्लाई नोडल एनालिसिस. बाय नोडल एनालिसिस एट नोड VTH. Okay, so VTH minus 4 by 2k. Okay, entering current minus VTH by 4k, leaving current is 0. ठीक है, then what is the LCM sir? Take LCM, you will get 2 VTH minus 8 minus VTH equal to 0. आपका VTH कितना होता है सर? 8. VTH तो मिला सर, फिर क्या करना? ISC निकालो. VTH तो मिला, फिर क्या करना सर? ISC निकालो. ISC निकलेगा, लेट्स ट्राई. How to find ISC? Listen. ठीक है, so let's find ISC. ठीक है, so for finding ISC, I short circuited. Whenever I short circuited, आपका Vx कितना हुआ? 0. If Vx is 0, the dependent source becomes 0. Dependent variable 0 हुआ तो dependent source 0 होता है ना. You can remove this by open circuit. Then what is ISC? 4 by 2k plus 3k, 0.8 milliamperes. What is the RTH sir? VTH by ISC, that will give you 10 kilo ohm. That's all. Okay, that is how you need to deal with this particular question. That is here Thevenin's equivalent, how to निकाला. Listen here, आपका RTH can be positive, can be negative also. Okay, आप लोग ट्राई करना चाहिए तो ट्राई करो. मैं एक प्रॉब्लम होमवर्क देता हूँ, प्लीज लिसन. वेयर इज दैट? यस, इसको इस वाला क्वेश्चन लो. सॉरी, प्रीवियस क्वेश्चन तो नहीं, मैं देता हूँ, डोंट वरी. इस वाला क्वेश्चन में ट्राई करो आप थेवेनिन्स इक्विवेलेंट. ओके, मैं तो होमवर्क दे रहा हूँ. फाइंड थेवेनिन्स इक्विवेलेंट. इसमें आपको RTH कितना आएगा? -100.5. RTH can be positive or negative also depending on the what we call, because the dependent source can deliver or absorb also. It depends on the network. In the first case, that is first model, if you have only independent source, RTH हमेशा positive होता है. But if you have dependent source, because it is an active network, its RTH can be negative or can be positive also. You can try this question at home. So let's do this now. Okay, so I hope you can see there is a link pasted in the chart. If anybody having doubt regarding the resistance, what is RTH, what is R in, नेगेटिव रेजिस्टेंस क्या होता है, सब पॉइंट्स आपको डाउट्स है तो वो लेक्चर देख लो. मेरा लेक्चर है, वो वाला स्पेशल लेक्चर देखो, आपको सारे डाउट्स क्लियर हो जाएंगे. ओके, इज इट क्लियर शिवम? प्लीज गो थ्रू दैट लेक्चर, आपका सारे पॉइंट्स क्लियर हो जाएंगे. जनरली रेजिस्टेंस नेगेटिव का मतलब इट इज नॉट एब्जॉर्बिंग, इट इज डिलीवरिंग. ओके ओके, so Bhushan, it requires 1 hour time, not 30 seconds. So what I will suggest you is please go through that lecture. Your सारे doubts, इसमें 2 लेक्चर है, एक लेक्चर के बाद एक और लेक्चर भी मेरा प्रोफाइल में मिलेगा. Please go through that. Every single doubt will be cleared. Generally input resistance is nothing but input voltage by input current. That is the resistance seen from the input. Okay, that is a Unacademy free lecture. It is not in the YouTube playlist. Okay, please go through that, Amit. Chalo, let's do this question. Determine the Thevenin's equivalent across A and B. Okay, if it is a comprehensive course, I explain every single detailed point. Because it is a crash course, I am going little fast. Please understand that. To complete your syllabus on time, because your exam is very near. So, dekho bhai, in that case, I took 75 lectures in the comprehensive lecture. Here I took some 22. I am planning to complete the total. Not around 20 में मैं तो complete करना चाहिए. Okay, but lectures are 1.5 hour duration, so around 30 lectures. So accordingly, I will go little fast. So please listen here. So this is the question given. Determine the Thevenin's equivalent of the network across AB. 1 minute guys. इस केस में मैंने RTH कैसा निकाला? VTH by ISC. Is there any other method to find the RTH, sir? Is there any other method to find the RTH, sir? Yes, there is another method. What is that method? Make this source 0, apply voltage here, find V by ratio. In that way also you can find it. I will show you that. Listen here. Okay, suppose in this question, not determine the Thevenin's equivalent, determine RTH. For example, this is your question. VTH is not required, only RTH is required. How to do it? Let's do it. You have both independent and dependent, right? This is the frequently occurring model guys from the Thevenin's, that is both independent and dependent. Suppose see here, I will show you. For example, you want to find VTH. I will show you how to find VTH. This is VTH. So this node voltage is VTH. Let us take this node voltage as V. What is Vx? If this is V, these two elements are in series na. What is Vx? V into 2 by 2 plus 3. So 2V by 5. Leave it. Listen here. Now, if you apply nodal analysis at the node V, okay? So V by total resistance 5 minus 10, V minus VTH by 5 equal to 0. Take LCM, V minus 50 plus V minus VTH equal to 2V minus VTH equal to 50. Okay, equation 1. Next, listen here. चलो इस वाला नोड पे भी नोड एनालिसिस अप्लाई करो. VTH minus V by 5 minus Vx by 4 plus 0 equal to 0. So So VTH minus V by 5. What is Vx, sir? What is Vx? 2V by 5. Okay. So now take LCM. 2 VTH minus 2V minus V equal to 0. 2 VTH equal to 3V. You can solve the equation 1 and 2. You will get VTH equal to 150. V is not required, but if you want, you can calculate V equal to 100. Right, this is how you need to find the VTH of the network. For example, if RTH is required, what to do? One method is to find ISC. After finding ISC, find the RTH equal to VTH by ISC. Let me do by that method. Just a minute. Okay, listen here. Let's try to find ISC. If you short circuit this current is called ISC. What is this node voltage? It is called 0 volts. Okay. Now listen carefully. Listen carefully. इस वाला नोड पे वोल्टेज V ले लो. What is Vx equal to voltage division principle से 2V by 5. Okay. Let's apply nodal analysis. Don't remove this because Vx is not 0. Vx is not here, na? Vx is here. You should keep it as it is. So V by resistance 5 minus 10 plus V minus 5 by 5 equal to 0. V minus 50 plus V minus 5 equal to 0. कुछ गलत किया? V by 5 minus 10 V minus 0 0 0. Okay. So V equal to 25. So आपका Vx क्या होता है सर? 2 into 25 by 5. 50 by 5, 10. Next. Then apply nodal analysis. By nodal analysis, at node 0, 0 minus V by 5 minus Vx by 4 plus ISC equal to 0. So minus 25 by 5 minus 10 by 4 plus ISC equal to 0. आपका ISC कितना होता है सर? 7.5. आपका RTH कितना होता है सर? VTH by ISC. It is equal to 150 by 7.5 which is 20. सर इतना करना चाहिए क्या सर? कुछ शॉर्टकट बताओ सर RTH निकालने के लिए. सपोज RTH का क्वेश्चन दिया, वी कैन नॉट डू डेफिनेटली दिस मच. ठीक है, सो शॉर्टकट से RTH कैसा निकालना? लेट अस सी हाउ टू फाइंड RTH. Okay, please listen here. Very simple. For finding RTH, replace the current source with a open circuit. मैं तो current source को open circuit किया, and here you connect the voltage V. Assume current I is flowing. ठीक है, so RTH क्या होता है सर? V by I. बस simple question. Now how to do V by I sir? Listen here. This is V. आपका Vx क्या होता है सर? Listen. V into 2 by 2 plus 3 plus 5. That is V by 5. Listen here. Now, if you apply nodal analysis, so at this node, V by total resistance, entering current Vx by 4 minus I equal to 0. V by 10 bx कितना v by 5 ना, minus v by 5 into 4 equal to I. So you can take 2v minus v equal to 20I. What is v by, sir? 20. That is your RTH. That's all. Simple. 4 steps you will get the answer. Same answer na? एक doubt आएगा आपको. I will ask you one doubt. Tell me, suppose you have a resistor 10 ohm parallel with some other resistor. What is the answer, sir? 10 parallel with something will be less than 10 or more than 10? Tell me. If you have a 10 ohm resistor parallel with some other resistance, resultant will be less than or equal to 10 or more than or equal to 10. Please comment. Tell me. If you have only independent source but no dependent source, Pushpendra, in that case RTH हमेशा पॉजिटिव होता है, लेस देन 10. ठीक है, इस केस में देखो ये तो 10 है पैरेलल विथ समथिंग, बट मेरा आंसर तो 20 कैसा आया? आई हैव 10 ohms पैरेलल विथ समथिंग बट माय आंसर इज मोर देन 10. 20. हाउ इट इज करेक्ट? टेल मी. इज इट क्लियर माई क्वेश्चन? मेरा क्वेश्चन क्लियर है ना? मेरा 2 + 3 + 5 तो 10 है ना. 10 पैरेलल विथ एनीथिंग शुड बी लेस देन 10, बट व्हाई आई गॉट मोर देन 10? टेल मी. Give me your answer. Give me your answer. Yes. What is that? Sir, the dependent source voltage can be, comment dependent source का current बताओ, because the dependent source का resistance high doesn't matter here. Again you are wrong. Not high or low, it can be negative, it can be any. You keep 1000, 1000 you take, say 1000 parallel with 10, sir. Check it if you want. 1000 into 10 by 1000 plus 10 ले लो, it is always less than 10, no doubt in it. You take 1 lakh parallel with 10, you will get less than 10 only. Anything parallel with 10 is always less than 10, but which case may you get more than 10, sir? It is when your resistance is negative. When your resistance is negative. Now let's go back with the basic concept. You see the dependent source. You can find RTH like this also na. RTH is equal to 10 parallel with the resistance of the dependent source, which I am writing as Rx. Rx क्या है sir? Resistance of the dependent source. Now what is the Rx, sir? What is Rx? It is its voltage V by current Vx by 4. Now please see the current direction. It is negative to positive. If the current direction is positive to negative, positive impedance. If it is negative to positive, we should consider it as negative impedance. Okay. But what is V and Vx? Vx equal to V by 5. Substitute here. Minus V by 5. It is by 4. It is minus 20. Now you substitute here and calculate. 10 into minus 20 by 10 minus 20. It will give you minus 200 by minus 10. What is the answer, sir? Yes, tell me, sir. Minus 200 upon minus 10, which will be 20. This is another way, if your basics are good, without doing all this stuff, simply by this method you can find the answer. Okay, so this is our own method to find the RTH. You can find the resistance of the dependent source by using the simple concept of its voltage current ratio. Arrow direction negative to positive, negative impedance, positive to negative, positive impedance. Any queries you can ask now? Clear? Okay, if it is a positive value for parallel with 10, answer is always less than 10. Whether it is a high value, low value, doesn't matter. Any positive value parallel with 10 always give you less than 10 only. Yes, tell me. क्या हुआ? मेरा मोबाइल स्टक हो गया. जस्ट ए मिनट, आपका कमेंट्स नहीं दिख रहा है. Okay, right? Very good. Pratik, you need some little basics, then you can watch. Not this one, see comprehensive course. Okay, so this one you can take it as a homework. मैंने दिया already. Next, see here, this also you take it as a homework. आपका आंसर कितना आएगा? 7 ohms. नेक्स्ट, ये भी होमवर्क ले लो. क्या सर सारे होमवर्क दे रहा है? नहीं. लिसन हियर you observe this question. The question is determine the Norton's equivalent between AB. Norton's or Thevenin's, whatever may be. Can you see any independent source in the network? Can you see any independent source in the network? No. So in that case, if only dependent source, no independent source, आपका VTH कितना होता है? 0. ISC कितना होता है? 0. How to find RTH? Multimeter method. What is RTH, sir? V by ratio. RTH is non-zero, remaining all zeros होता है. So let me do RTH. You can do by conventional method. Otherwise, please listen. ठीक है, चलो. Now listen here. This is the network. This is the network. Please listen here carefully. One method I told, find voltage current ratio by using multimeter. नोड एनालिसिस से ट्राई करो. एक मेथड का आपको आंसर मिलेगा. मैं तो एक शॉर्टकट दे रहा हूँ आपके लिए, मेरा ओन शॉर्टकट. How to do this question, sir? Listen here. If this current, you assume here some voltage is applied and some current is flowing. RTH equal to Vx upon Ix. This is true, no doubt. But another way to do the same question is, if it is I, what is this drop? 4I. Then parallel voltage should be same, na? This is also 4I. Okay. If it is 4I, okay, what is this voltage? It should be 4I. Then its drop should be equal to how much? You tell me. You tell me. Parallel voltage should be same. It is 4I. It is 4I. For that current should be 2I. No doubt in it. But parallel mein voltage should be same. Here also you should have 4I. If you want to have 4I here, what is this voltage? 0. If that current is 0, voltage is 0, this current should be 0. Then what is the resistance of the dependent source is its voltage by current, which is infinity. Then what is your RTH is 4 parallel with 2. 4 by 3 is the answer. Simple question. Okay. You can do the same question by conventional node analysis, find V2I ratio at home, you will get the same answer. But my trick is, if this is parallel with this, voltage is same. This part is parallel with this, voltage should be same. If voltage is to be same, then this drop should be 0. If this drop 0, current 0 means V by ratio is infinity. You can replace this with a open circuit. Suppose here you get 2I, then you should take it as 2I, then 2I by 2, current will be I, then resistance will be voltage by current. That is how you can solve the questions more simply. We'll apply this technique in most of the problems easily to solve the questions. Is it fine? Okay. Somebody got the answer, Siddhant, you got the same answer by a different method. This is my shortcut to do the question. Any doubt, please ask, otherwise we will move further. Yes, dependent source impedance is negative means what? When you apply the voltage instead of absorbing, Mahesh, it will deliver. Okay. चलो नेक्स्ट क्या हुआ, ये कहाँ से आया, राइट. सो दिस इज अबाउट योर द नेक्स्ट थ्योरम. टुडे आज मैं थोड़ा सा जल्दी छोड़ूंगा क्योंकि मेरा 7 PM पे एक स्पेशल क्लास, 8 PM पे एक और स्पेशल क्लास है. सो 6:45 छोड़ेंगे सारे को. जस्ट लास्ट 15 मिनट्स प्लीज कॉन्सेंट्रेट प्रॉपरली. ठीक है. सो लेट्स कंटिन्यू. So this is the next theorem we need to discuss, maximum power transfer theorem. ये maximum power transfer theorem का बात क्या है सर, इसका advantage क्या है सर, what is the use of maximum power transfer theorem सर. Listen here, maximum power transfer theorem कब help करेगा सर हमको. मेरा पास एक source है, source का कुछ internal impedance भी है, इसको मैंने load connect करना चाहिए. वो load तो variable है. Okay. So I want to find the value of the load such that मुझको maximum power मिलेगा from the available limited source. When I am not able to increase the source value, to get my required condition, when the power source available is limited, but my load is a variable quantity, by adjusting the load to the required condition, I will achieve more power to my load. For example, in the audio system, you are varying your volume. कुछ वॉल्यूम आप ऐसा चेंज किया तो एट सम पर्टिकुलर पॉइंट आपको बहुत ज़्यादा साउंड आएगा, आपका आउटपुट ज़्यादा होता है. दैट इज व्हाट वी कॉल मैक्सिमम पावर ट्रांसफर कंडीशन. दैट इज गिवन बाय दिस थ्योरम. दिस थ्योरम विल गिव यू द कंडीशन फॉर द वैल्यू ऑफ द वेरिएबल लोड फॉर मैक्सिमम पावर ट्रांसफर फ्रॉम सोर्स टू लोड. ओके. सो प्लीज लिसन हियर. इसमें दो केसेस होता है, डीसी केस और एसी केस. पहले हम डीसी केस डिस्कस करेगा. डीसी केस का मतलब क्या सर, मेरा सोर्स इज ए डीसी सोर्स Vs with a internal resistance Rs. Okay, fine. For that I have connected a load which is a variable RL. Okay. So what is the question? What is the problem we are doing is, I want to vary this load such that I get more power, maximum power from here to here. ठीक है. So आप लोग मेरा load है, ठीक है, आप भी vary होता है. So when your strength is very high, मेरा आउटपुट ऑल्सो वेरी हाई, मेरा एनर्जी ज़्यादा होता है. दिस इज ऑल्सो वन काइंड ऑफ मैक्सिमम पावर ट्रांसफर थ्योरम. ओके. सो आई एम योर सोर्स, यू पीपल आर मेरा लोड. सो आप लोग कमेंट किया, आप लोग अच्छे से समझ हो गया, आप लोग अच्छे से रेस्पॉन्स दिया. दैट इज माई वेरिएबल लोड. एट सम व्हेन द रेस्पॉन्स इज वेरी गुड, माई delivering output will be very high. I will give you maximum possible power to you. That is what we call maximum power transfer theorem. Okay. Similarly here, you have a fixed source, a variable load. At one value, you get more power from here to here. That value we are calculating. As a designer, when you connect a load, when you have a limited source, to get the maximum power, you should keep that value. You should match that. Okay. So what is the current here is voltage by impedance, where power is equal to I square into load resistance RL, that is this square into RL. Now what I need to do, I need to find the value of RL for maximum power. So what I will do is d by DRL of power equal to 0. If I make d by DRL of this equation equal to 0, finally the conclusion I will get is RL must be equal to RS. What is the condition I will get for maximum power transfer? My load resistance must be equal to source resistance. So when RL equal to RS, what is the power, sir? In the power equation, substitute RL equal to RS, you get V square into RS by RS plus RS whole square, which will be V square by 4RS. Okay. So if you see here, if you increase the resistance beyond RS, what happens is your power will decrease. Suppose you have an audio volume button. You increase to one particular value, volume increase. After that, physically we stop that button. Okay, if you see old what we call audio systems, you will be having a volume control, which you knob is there, which you move like this. At one point, physically it will stop. It doesn't mean it is the highest resistance. After that, if you increase, what happens is your volume will decrease, your power will decrease. That's why this is the condition where you get maximum power. इसके बाद फिर क्या होता है, power कम होता है. So this is the condition when will you get maximum power, when RL equal to RS. ठीक है. So for example, see here, let's calculate efficiency. Let me do derivative. Okay. So what is the efficiency of maximum power transfer theorem? Let me take a black background. ज़्यादा दिन हो गया. Okay. So what is the efficiency of the maximum power transfer? What is the efficiency is given by useful power by total power. That is, what is the useful power? Power taken by the load. By total power is supplied for two people, internal resistance or load. Okay, this will give you the maximum power transfer condition. Okay, so here, if you substitute RL equal to RS, because under maximum power transfer condition, what is the efficiency you will get? RS by I square cancels into 100%. You will get it is equal to 50%. What does it physically mean, sir? Under the condition RL equal to RS, no doubt मुझको maximum power मिलेगा. So for example, for a fixed load, maximum power it can give is 200 watt. So if you increase the load beyond that, you never get more than that. No doubt in it. But to give that, load कितना generate कर रहा है, sir? It is generating double. That is, half is taken by internal resistance, only half you will be getting. So efficiency point of view, it is 50%. That is, if you are ready to sacrifice 50% of generated power, that is, you are happy for getting maximum power, but you need to pay bill for both the cases. So whenever source is limited, then only we should use this theorem. Okay, it depends. So please listen here. For this example, this example, see here, मेरे RS and RL equal किया, different किया. So इस केस में efficiency कितना आया मुझको, useful by total will be 90%, around, approximately, not exact. But if you take both same, you get 50%. But here power will be maximum. Here what is the load power is minimum. So there is no, you understand here the value of power will be high, but efficiency wise it is less. Okay. So for example, similarly you can take a speaker. Let me give you this understanding. Suppose I have a coil of 8 ohm resistor. I have connected to a 32 volts with an internal resistance RS. So what is the current is 32 by RS plus 8. So power is I square into 8. Let me vary that RS 8, 4 and 0 and calculate the powers at when RS equal to 8, RS equal to 4, RS equal to 0. When will you get maximum power according to the theorem? Theorem से maximum power कब आना चाहिए सर? When RL equal to RS. But इस केस में maximum power कहाँ आया सर? What it indicates? What it indicates is this theorem is applicable when RL is variable, your derivation is made by making dP by dRL equal to 0. When RS is variable, generally it is not happen, but problem में ऐसा दिया तो you should not apply this theorem. Don't apply this theorem when RS is variable. This theorem is applicable only when load is a variable quantity. If load is a fixed quantity, choose minimum internal distance. इसका internal distance कम किया तो आपको maximum current मिलेगा, then you will get maximum power. Okay, if it is a current source, you should choose the internal distance as high as possible. Okay, any doubts, please ask. Any queries, please ask. वेरी गुड. चलो फिर एक प्रॉब्लम करेगा. दिस इज द एफिशिएंसी ऑफ द थ्योरम, ये तो डिस्कस किया. सो प्लीज रीड दिस क्वेश्चन. वी विल डू दिस क्वेश्चन, प्लीज रीड इट. चलो रीड द क्वेश्चन, वी विल डू इट. ओके. सिद्ध पुराना वाला पीडीएफ में सारे आंसर्स हैं. यू कैन गो थ्रू इट. आई विल गिव दैट ऑल्सो. आई विल ट्राई नेक्स्ट टाइम ऑनवर्ड्स. पीडीएफ अपलोड करने समय में देता हूँ. ओके चलो. So the practical DC source, when it is momentarily short circuited, provides a current of 2.5 ampere. It can deliver a power of 80 watts to a 20 ohm load. Determine the value of the load resistance to be connected for maximum power transfer. Let's do this question. You have a practical DC source. When it is short circuited, you will get a current of 2.5. Fine. Okay, so what is I? Vs by Rs. This is 2.5. So what is your Vs, sir? 2.5 into Rs. Okay, next. Okay, so the second case is it can provide a current of 2 amp. It can deliver a power of 80 watts to a 20 ohm load. आप connect करो 20 ohm load. आपका power कितना? एग्जामिनर के तरीका से I square into 20 equal to 80. That is I square equal to 4. Your I will be equal to 2. But what is I in this figure? Vs by Rs plus 20. So what I will get here is Vs equal to 2 times Rs plus 40. This is one equation and this is one equation. If you solve the equation 1 and 2, you will get Vs equal to 200 and Rs equal to 80. That's all. So please listen here. Vs is equal to 200, Rs equal to 80. So what is the condition required for maximum power transfer? As per just now discussion, your RL must be equal to 80. RL must be equal to Rs for maximum power transfer. What is the current I? It is, sorry, why to calculate current? What is the formula for P max? Formula V square by 4 into Rs. Bas, you can do this calculation part. 125 watts you will get. That's all. Just use the information given by examiner in a proper way. That's all. Right? Thank you, Roy. Okay. So it's almost 8:45. Okay, so then actually I have a class at 7 p.m. Then what we will do, we can wind up for today. फिर मिलेगा कल क्लास में बाकी क्वेश्चंस तो करेगा. मैं कल क्लास में ऐसा सोच कर रहा हूँ, मैक्सिमम पावर ट्रांसफर को ख़त्म करेगा और रेसिप्रोसिटी, इसके बाद क्या मिलीमैन्स डुअलिटी सब्स्टिट्यूशन सभी पॉसिबिलिटी है तो ख़त्म करेगा, नहीं है तो नेक्स्ट वाला क्लास में वी विल कंप्लीट दैट. देन वी विल मूव टू टू पोर्ट नेटवर्क्स. ओके. So today is Wednesday, right? Thursday is there. Friday, Saturday. Yes, by Saturday I want to finish what we call two port networks. Sunday तो एक 3-hour session will be taken on transient. Morning we are already going with AC analysis. So today phasor diagrams is completed, and tomorrow resonance. Then next day average and RMS values. Like that, in the available time, I will try to give you the best. If you want every single detail, then you should go for my comprehensive course, that is a 75 hours course. Now because it is an exam time, I am giving you in the shortest possible format so that those who don't have much time can be able to get benefited. Okay. So if you want the complete comprehensive from the basic 0 level to the required level with every single detail, go with my comprehensive course, which is available in the playlist of the Kreatryx channel. 75 lectures are there for you. You can go through that. Okay. Thank you very much guys for today. So एक important announcement. So if somebody want to start GATE 2022 or 2023 का preparation, the first point to start is to start with the network analysis. So come to our platform. I am starting today 8 p.m. a complete free special class. Just download the Unacademy app. If it asks the code, you just apply the coupon code Shankar10. 8 p.m. get ready. We will start the foundation course for the network. That is from the basic level. What are the type? Suppose in the crash course we went little fast. For second, third years के लिए, not for final years or those who are appearing this year. Second, third years के लिए this class will be helpful. Okay. Those who are want to start the preparation, this will be like a first class for them. So in the Plus platform, I mean Unacademy platform, I will give you the teaching with live interactive doubts. There you will be having clearing your doubts will be more easy. Right? So today 8 p.m. onwards I am starting. I planned 5 lectures of each 2 hours duration, 10 hours to give you the foundation of the network. That will help you to read all other subjects also. So if any of your second year, third year friends are there, you can inform them. So today I am going to start this. You can access that with the help of my coupon code Shankar10, which is free for you. So listen here. These are the what we call this particular weekend marathon sessions, which are completely free for you in our channel. Laplace and jet transform by our Vishal sir, and a differential amplifier completely by our Kamesh sir. You know, Vishal sir is the expert for signals and systems. Similarly, Kamesh sir EDC unlock के लिए you cannot find any alternative for Kamesh sir. ठीक है? Similarly, my class transients for you, which is a regular continuation but 3 hours duration on the coming Sunday, guys. Okay. So yes, you can follow the Telegram channel. मैं तो सारे notes अभी तक कल night पे upload किया. Daily I will upload the notes in the file section of the Telegram channel. Thank you. फिर मिलेगा special class में, आप लोग आना चाहिए तो आ सकते हैं. Okay. You can come, Ananya Roy. You can some little basic if you have, you can come. Raghavendra, for that work is going on. Okay, regarding that. Thank you. Love you all. Bye bye.